Hello and welcome to another Moody Moose Math movie where you get to play the therapist and solve all of math's problems. Today we're going to start chapter 4, covering 4.1 Domain and Range of Functions, which begins on page 150 in your book. That's page 150. And as you before we start any chapter, we're going to have to start with some groundwork and some terminology, some things that you're going to need to know, some words that you'll hear over and over as we go through this chapter, so you need to know what they mean. The first word that we're going to have to know is a function, okay? And in a function, we have one input with exactly one output. Okay, here's an example of a function right here. So what is an input and what is an output? Okay? An input, another word for input, is going to be the domain. And an input is any x value that you put into an ordered pair. So it's whatever we put in for the variable x. Okay? The range, or the output, is the y, and that's going to be a result of whatever you get when you put in your input. That's a lot of words that I just said there. So let me give you an example. Let's say we had an input, okay? Let's say an input of 2, okay? So we make x to be 2. And that's our input, or our domain. It's the x value. So we're going to put it into this function, and we're going to make x 2. So let's rewrite this function, and instead of x, we're going to put 2 in there. Okay? Now let's see what our output or our range is. When our input is 2, our output, or y, is 3 times 2 is 6. Okay? So our input would be 2. And when our input is 2, our output is 6 for this particular function. Alright, here's example number 1 in your book. And you'll see that we have a graph. And we have the dots here, 2, 3, 4, right there. And the instructions want us to find the domain and the range that is represented by this graph. All right? So our domains are going to be all of our x values. Okay? Those are going to be the x values. And our range is going to be all the y values. All right? So let's do the domain first. Let's start with this point here. What is our x value of this particular point? -1, -2, -3. So one of our domains is -3 is part of our domain. Now we got to go to the next dot. This one here. What's the domain of this point? -1. Right? So we put -1 is our domain. Another domain that we have is 1. And the last domain that we have is 3. Okay? So our domain is -3, -1, 1, and 3. Okay? Domain meaning the x. Okay? Now let's tackle the range, or the y. Okay? The y coordinate. This dot, right, let's go to this point. This point has a range, or a y coordinate of -2. Okay? -2. The second point has a range of 0, the third point, range of 2. And then the fourth point, all the way to the right, is 4. So we would say that our domain consists of -3, -1, 1, and 3. And our range is -2, 0, 2, and 4. Okay, here's an example that I want you to try on your own. You are going to do the same thing that we just did. Find the domain and the range of this function represented by the graph. So pause the video and then unpause it when you think you have the answer. Alright, let's see what we got. For our domain, working left to right, our x values are -3. Our second point is -1. Our third point would have an x value of 1. And our last point would have an x value of 3. So our domain should be -3, -1, 1, and 3. Our range is going to be -3 for the first point, -3 for the second point, -3 for the third point, and -3 for the last point. When you have more than one, like we do here, okay, you only need to write it one time. So you could have just wrote -3 and that would have been perfectly acceptable. No need to write it more than one time. Alright, here's another word that we're going to need to know because we'll be using it in the next example, and that word is function form. Make sure you know this. An equation is in function form when it is solved for y. In other words, when y is isolated all by itself. So this right here is not in function form because it's not solved for y. Y is not isolated. This equation in function form, where you would subtract x to isolate y, would look like this. This one is in function form. Okay? What about this one? Is this in function form? Yes or no? It's not, because y is not isolated. You have the 1/2 being multiplied. Y has to be by itself for it to be in function form, okay? What about this one? You should immediately know the answer right now. Okay? That one is in function form because y is isolated all by itself. We're going to be putting equations into function form so that we can plug in values for x, our input, to see what our output is going to be. We're going to do that right now in example number 2. Alright, here's example number 2, and in this one they want us to find the range of the function. So I'm not going to write all this out, so if you want to read along, it's on page 151 in your book. But it says the domain of the function is represented by 2x plus y equals 8. And the domain of this function is -2, 0, 2, 4, and 6. What they want us to find is, what is the range? Okay, so they give us the domain, they give us the x, remember from the beginning, domain is the x, and they want us to find the range or the y. Okay? The first thing that we have to do to solve this, to find the range, is to get it into function form. Okay, that's why the last slide was so important. Function form, remember, is when y is isolated. Is this in function form? No, it's not. So the first thing to do is to put this in function form. Solve for y. To do that, you're going to subtract 2x from both sides, leaving you with y equals a -2x plus 8. And I got that because I subtracted 2x from this side, which leaves me with 0, or just y. And I subtract 2x from this side, so I get a negative 2x plus 8. Alright? That's step 1. Step 2, 3, 4, 5, and 6, is to plug in our domains into this function to see what we get for y, for our range. Okay? So we can start that now. Let's plug in our domain or our input of negative 2. Okay? When our input is negative 2, what is our range? Well, we have a negative 2 times a negative 2 right here. That gives us 4. Okay? 4 plus 8 is 12. So then our range, when our domain is negative 2, is 12. Okay, so what I've done is I've moved our original problem up here. Okay? And I've started to work out the rest of the domain. So here we had our domain where we plugged in a negative 2. Okay? And we got y equals 12. So we know that's part of our range right there. What we need to continue to do is use this equation in function form and plug in the rest of our domains, which is what I've done. We did negative 2 here. So now I'm going to use this in function form, but instead of negative 2 this time, I'm going to plug in 0. Negative 2 times 0 is 0 plus 8, y equals 8. Then I do the same thing for 2. Plug in 2 to this in a function form. Negative 2 times 2 is a negative 4 plus 8 is 4. Then I'm going to do it for the 4. Okay? Negative 2 times 4 is a negative 8 plus 8, and I get y equals 0. And then the last one that I have to do is I have to plug in 6. So I do negative 2 times 6 plus 8. Negative 2 times 6 is going to be a negative 12. Negative 12 plus 8 is going to be a negative 4. Okay? So now I have all my ranges, and my ranges are, I'm going to put R for range, 12, 8, 4, 0, and negative 4. Okay? So the original problem was, what is the range of this function? Your answer is going to be 12, 8, 4, 0, and negative 4. Alright, here's the on your own example number 3. Okay, here's your equation. It is in function form, so you don't have to put it in function form. That saves you a step. And your domain values that you need to solve for are negative 1, 0, 1, and 2. So pause the video, work it out, and then unpause and we'll see if you got the right answer. Okay, when you plug in negative 1 for x, you should get y equals 2 times a negative 1 minus 3. 2 times a negative 1 is negative 2, and you're going to subtract 3 more, so y is going to be a negative 5. Then you're going to do the same for 0. Y equals 2 times 0 minus 3. 2 times 0 is 0 minus 3 is y equals a negative 3. Plug in 1. Y equals 2 times 1 minus 3. 2 times 1 is 2 minus 3 is a negative 1. And then plug in 2. 2 times 2 is 4. Minus 3 and y equals 1. And so what we have is our range of y equals negative 5, -3, -1, and 1 right here. Alright, that should do it for this edition. Now to wrap up with our joke of the video. Why did the bicycle fall over? Because it was too tired.